Hi everybody, I'm Lee, and I'm here to talk to you a little bit today about Nagle and how it's been implemented in TCP, and specifically around the Linux kernel. As I said, my name is Lee Finch. I'm here because I love talking about technology. You can find me on @LeeFinch1 on Twitter, or you can hit me up on LinkedIn with the QR code down the bottom left-hand corner. So Nagle is a pretty cool algorithm. It was introduced in around 1984 by a man named John Nagle, and it was designed to address what was known as the silly window syndrome or the small window syndrome. And that is essentially a problem where we end up sending too many small packets across the internet, or across any network, in fact. And what the Nagle algorithm decided, or what John Nagle decided to do with the Nagle algorithm, was to implement a non-timer based approach to transmitting data more efficiently. And then later on in RFC 1122, which was in the late 80s, it was actually stated that we must address the small window syndrome, and that we should, not must, use the Nagle algorithm. So some implementations allow you to disable Nagle. I'll talk about that in a second. But for the most part, you will see Nagle out there and about to make your communications more efficient. And the algorithm is pretty simple. It essentially says that if a full maximum segment size can be sent, send it. If less than a full maximum segment size cannot be sent, we've got two situations that might happen. One is that we have unacknowledged data on the wire. That means that we haven't seen an acknowledgement come back for some data that we've sent over the internet. And that means that we're going to queue the data. Nagle says, don't send the data until I get an acknowledgement back. So it's going to queue and queue and queue until the maximum segment size occurs, in which case the data can be sent, or it waits for an acknowledgement to come back for that data. However, if all data is confirmed and acknowledged on the wire, send the smaller the maximum segment size with the push flag. So you've got a situation where that if you've got full size data, send it. Bulk transfer, send it. If you've got small data, and this is the case with databases, and this is where you run into problems with request response type applications, you might have to wait for acknowledgement to come back. Now, in applications that do have that small type messages going back and forth, so databases, RPC, Windows file sharing as an example, you can actually disable this behavior by setting the socket option TCP no delay. But that is as much as the application can influence Nagle. It can either turn it off or it can leave it on. So what I want to do now is I want to actually go into some packets. So I've got here a really, really simple application that's going to go off and send a very, very small payload, which is this payload right here, 1234, and say, don't echo that payload. Don't send me any data back. It's just going to send data to the server. The server's going to go, that's awesome. I'm going to not reply to it with any payload. Eventually, the server will acknowledge the payload, depending on the delayed act configuration, etc. I'm then going to sleep for 35 milliseconds, and then I'm going to send the payload again. Then I'm going to sleep for 1 second, and then shut the connection down. So if I go over here, I'm going to disable that. I'm going to, close that application, or close that script. I'm going to run that script now. And that's going to run and create me a virtual network inside Mininet that will then send some payload over a 100 millisecond connection, and we'll see exactly what happens in terms of Nagle. So it's actually finished now. I'm going to switch back over here. I've got some packets here with Nagle enabled, and I'm going to open up Wireshark, and there's a couple of things that are kind of interesting. I'm going to filter first on the first TCP stream. And here we have our packets. So, first things first, we've got our Hansang Ack, and there's a couple of interesting things in the Hansang Ack I'm going to show you. One of them is how we calculate round trip time, and the other is some of the TCP options that are shared as part of the opening sequence. One of those is the maximum segment size. So we sent a very, very small amount of payload, we've definitely sent less than 1,460 bytes as part of that application. I'll show you that in a second. Selective acknowledgement is enabled, and we've also set the window scaling to 9, which has multiplied the value by 512. So we then have the delta between the SYN and the ACK, and if I actually change that view from time to seconds since the first capture, we end up sorry, not that one, sorry, what I'll do is I'll time shift that. So I'm going to set the time reference to 0 there, and you can actually see here I've got the delta between the SYN and the ACK is 108 milliseconds. And if I go down to the first payload, what you'll see down here in the sequence and ACK analysis here is that it's calculated the round trip time at exactly 108 milliseconds and 384 microseconds, and you can see that that's the value that we get here, exactly there. Now I've set up my connection, and I'm going to send some payload. So I'm going to send some bytes in flight here of 38. So that's my command here, and I'm going to wait. I've actually then starting to on-queue data, and I've waited my 35 milliseconds or so, and now I'm sending more payload and another 190 bytes in flight. But I've actually had to wait 105 milliseconds before I can send that. Now what's happened there is that Nagle has said I've sent 38 bytes. Now because I don't have a full payload, you can see here that's only 190 bytes that are queued, I'm going to have to wait 105 milliseconds for that payload to come back before I can send my next packet, no matter how much I do, or until I hit the maximum segment size rather. So that is Nagle effectively blocking this 190 bytes of payload from being sent to the server until 105 milliseconds later, when I get my acknowledgement back saying, yes, I've received that 38 bytes, there's no outstanding data on the wire, therefore I can send my next payload. And that is Nagle in action. So everybody, I want to thank you all for taking the time to watch this. Please, if you've got any questions, please hit me up in the comments. I'm going to link to a couple of videos that are really interesting. One of those is the Hansang Bae video on Nagle and Delayed Ack deadlock, and he goes through and explains this really, really well, much clearer than I do, around exactly the process that Nagle uses to transmit data and Delayed Ack and the interaction between the two. But from this video, what I really wanted to show you is just what it looks like on the wire. If you get a chance, have a look at some of the other videos. This one's really short. Some of the other ones are 25 minutes long, but they go through a brief history of TCP. I also, one of the other videos I have there describes TCP 0 windows and window full conditions. If you like it, please like and subscribe. Otherwise, have an awesome day and have fun.